Okay, welcome back. This is the second and last module of this chapter, and in this module, we are going to take a overview of what are indexes and what are different types of them, and uh, how beneficial they are, and how they are different from actually the file system that we looked at. So indexes are basically sort of auxiliary and additional data structure to speed up the query processing operations, and they are different from the file organization that we discussed. So essentially, even the indexes and data in the indexes is stored in the file system, but they are not the same as actual pages or files that are used by the database tables to store each record. And this picture actually gives you an idea. On the left hand side, what you have is actually a hashed file organization. So you have a table of students or a table of employees with name, age, and salary, and this entire table is organized as a hash file by hashing each record on the age attribute and then deciding which page to insert that record into. So as you can see, in this example we have considered 3 pages where if the hash calculated of the age is 00, then it goes to page 1. If the calculated hash is 01, consider it like a binary bits that you consider from the age integer value. And so if the hash of it is 01, then it goes to page 2, and if the hash is 10, then it will go to page 3. So this is the hashed file organization for this table. On the right hand side, whereas you have an index that is created on the attribute salary. Now this index is actually different from the file system organization, because if you can see, in this index, the index key is the salary of the employee, but the record actually that is already existing in the hashed file organization, its location does not get decided by the relative ordering among the index keys. So for instance, consider the salary 3000. So right at the top of the index you have two entries, one 3000, second 3000. The first entry points to page 1 and the record 1 in it, whereas the second entry points to page 2 and the first record in it. Similarly, if you consider the 5004 salary, then again you have the similar observation that the first entry points to page number 3 and the first record in it, whereas the second entry points to page number 1 and the third record in it. So as you can see, we discussed about searching and insertion deletion over file system organization. Here you can see the benefit is that you are actually creating one set of records and one set of organization of those records using file system, let's say in this case hash file organization. But to facilitate any other type of searches which are not on the hash, the key used in the hashing file organization, to facilitate those searches, we are creating this secondary data structure called indexes, which just creates pointers to those records. So I have been telling you in this course to get insights from other computer science domains as well, and here is another great insight that you have got introduced to the concept of pointers or references in object oriented programming languages. Then this is exactly the same, that you have one set of memory, in this case the hashed file organization, and but you want different access methods or quick decision about which record to go or which page to go and access it. So that's why you create a secondary data structure which just maintains pointers from that data structure to the original file system and records between it. So there are different types of ways to create these indexes. Three usual alternatives are that you have data entry K star, which is an actual data record. That means that it is a search key K, and then there is a data record associated with it too, along with it. Data entry can also be of the type K and RID pair, which means that K is the search key and RID is the row ID or the record ID of that of the row ID that has that search key. The third type is that data entry is K and list of RIDs, where the RID list is the list of record IDs that have value key in it. So we will take an example and see what is the exact difference between all three of them. So alternative K star essentially means that you don't need to store the data records separately. Only a record of sorted keys pointing to the location of the data record. And such an index is a special file organization that can be used instead of the sorted or a heap file. Now going back to our figure, actually this K star is, as the slide already said, that this is a special type of file organization, and as you will see in case of hash indexes, basically what we have done in this particular figure, on the left hand side we have the entire table or file organized according to the hash values of the ages and records inserted into appropriate pages. So this is nothing but an index in itself of type K star, where you have the age as the search key and entire record, that is, let's say Smith 44 3000 is also associated with that K as the search entry. The other type is KRID. So moving back to our figure, basically what this means is that in this figure you have 3000 first record pointing to page 1 record 1 and 3000 second record pointing to page 2 record 1. So this pointer that you have created is actually nothing but RID. So either RID is basically, it is assumed that row IDs, irrespective of the exact attribute values in the table, are always in sorted order. So in this particular case, when you have records stored in the page as Smith 44 3000, Jones for 46003, that means that Smith 44 3000 is going to have RID 1, Jones 46003 is going to have RID 2, and so on and so forth. So RIDs actually refer to the sorted order of the physical sorted of the rows on the disk, whereas these keys that we have used actually are not necessarily the exact sorted order of the records on the disk. So that is why whenever you are creating an index of type KRID, the RID essentially is a pointer to the record. So in this case, for 6000 entries, like at the bottom of the right hand side index, this essentially means that the RID associated with first 6000 is going to be 2, and the RID associated with the second 6000 is going to be 8. So the other type is, so here in this figure we actually I'm showing you just what we discussed, that on the left hand side you have an index, sort of an index of type K star, and on the right hand side you have an index of type K RID. So alternative 2 and 3 are independent of file organization. So this is the essential difference you have to understand between the first alternative, where every key has associated with it the entire data record, and alternative 2 and 3, where you have either K and RID or K of list of RIDs, where the physical ordering of the rows in the file is not necessarily same as the ordering of a particular key in that index. So I already explained that in the right hand side index, basically the salary value 6003 is at the bottom, right at the bottom of the index, because it's the highest value. But if you consider their row IDs associated with them, then the row IDs associated with them are not exactly sorted in that order. Or rather, more than this example, let's take an example of salary value 3000 and 5004, the second entry. So as you can see, the first 3000 value points to the first record, the second 3000 value points to RID 4, the fourth 5004 entry, that is the fourth entry in the index, actually points to row ID 3. So that is what I am trying to say, that the sorted order of row IDs is not same as the sorted order of the keys in the KRID kind of index organization. And KRID list is exactly same as KRID, just that instead of having only one row ID associated with the given key, you can have a list of row IDs. So I'll tell you on the hand note how this will look for this particular case. So we have 3000, 3000, and then 5004, and I'm not drawing the entire index. So this actually points to RID 1. So let me actually, so this actually points to RID 1. This points to RID 4, and this points to RID 7, and this one points to RID 3. So this is KRID organization. So in place of this, if you have KRID list organization, the way it is going to look is, you have 3000, and then along with it you have a list 1 4, and then you have 5004 and list 7 7 3 or 3 7. So that is how there is a difference between K and RID list. I would also want to tell you that you can go deeper into this, and which is what we are going to do from the next slide onwards. So there are more types into these indexes. So first type is the clustered index, where the actual data entries in the file system or data records in the data file, their physical order, storage order, is exactly same as the sorted order of the search keys. So going back to our previous slide, in this case actually this is not true. So on the left hand side what you have is actually a hashed index, but hash index actually the sorted order of the keys is not same as the sorted order of the rows, or rather there is no sort order between hash IDs and the associated records. So this is not a clustered file system. But when we see the other types of like B plus trees in from the next chapter onwards, you will appreciate what this is means. So this figure in itself actually is representative of a B plus tree index, and what this means is that if my index actually the entries in the index and their sorted order is same as the actual sorted order of the data records, then this is called as clustered index. So let's actually go back to the hand slide and see how the clustered file index in our example would look. So this actually was RID 1 and 4, and 5004 was 3 and 7. So I'm just going to, so 3000 had 1 4, and RID 5004 had 3 and 7. So this essentially meant that the first row had 3000 salary, then fourth row had 3000 salary, third row had 5004 salary, and then 1, 2, 3, 4, 5, 6, 7. This one had 5004 salary, and these are actually don't care positions, so you can actually 6003, 4003, 6003, and 4003, and one more is 2007. Okay, so I have replicated the entire original file from the disk from our slides, and this is our original hashed file organization. Okay, so instead of this, let's say we decide to get rid of the hashed file organization and turn it into sorted file organization, and the sort order is decided based on salary. So I reorganize these records into new pages, such as I have 3000 first, then again 3000, then I have 2007, then I have 4003, 5004, and 5004. Okay, yeah, so and then 6003. So these are the 7 records that we reorganized in the new file system, which is a sorted file order. And then if we consider the RID list of these index entries, then they are always going to be in sorted order. So essentially what this means is that all the RIDs of my 3000 entry are always going to be lesser than all the RIDs of 5004 entry. So in this case, this is going to be this is going to change to look like 1 2, and this is going to look like 1 2 3 4 5 6, 5 6. So as you can see, if 3000 in the sorted order of the index is lesser than 5004, then all the RIDs of 3000 are also going to be smaller than all the RIDs of 5004. So this essentially means that then I have a clustered index. However, what we had in our example was an unclustered index, which meant that the sorted order of the keys in the indexes was not according to the sorted order of the associated row IDs that are stored in the actual file organization. So this is the clustered and unclustered index. Then we have other types of index, which is dense versus sparse index. So dense index essentially means that if for every unique entry on the attribute that you are creating index on, if that entry exists in the index, then it is called as the dense index. So on the right hand side, we have an index on the field age, and as you can see that every unique age that exists and every unique entry also that exists in the original record list is there in the dense index at least. So notice that age 44 occurs twice in the original data, and it also has 2 entries in the index file. So this is the dense index. Whereas on the sparse index, which is there on the left hand side, for every page you create an entry into the index, and actually you don't record every you don't make a entry for every record and its key in the sparse index. So the benefit of sparse index versus dense index is that in case of sparse index, the size of the index remains small, so you can quickly go over that index without having to do lot of disk IO if the sparse index in itself is remaining on disk IO. Because its size is very small, you can oftentimes keep it cached in the memory, and you don't have to do disk IO at all. So you quickly locate the page. So let's say I want to find the entry Basu, I mean the name Basu. Then what I do is I look up my sparse index and compare the consecutive keys ashb and cas, and I know since Basu in the sorted order is going to come between ashb and cas, that means that it is going to lie on the first page which ashb points to. So I fetch that page and get the Basu entry by doing a sequential scan or binary scan on the records. As opposed to that, if you consider the dense index, first of all, the size of the dense index can be large if your size of the key and values associated with them, which you have used to create the index, itself is very large. So you might need to store that on the disk. Secondly, but the benefit is that you can do log of n to the base to search within these index entries, and then once you have located the entry, you can directly get the row ID of that particular entry and go to the page and fetch it. So in the textbook you will find some discussion about benefits and pros and cons of every, like dense versus sparse index, and I would like to tell you over here that when you consider database management system and index creation, there is no one golden index or one golden file organization that wins over all. Whether you consider clustered index or unclustered index, whether you consider dense index or sparse index, or otherwise whether you create dense or sparse index, all depends on the type of queries that you are going to get on your relational database and the any other factors associated with it. For example, if you are going to have more insertions, whether you are going to have more updates, whether your database is going to be more just lookup or read only database. So the choice of indexes and file organization often depends on the type of queries that you get and type of updates and frequency of updates that you get. And you will see that as we move on to query optimization component, which makes the heart of the database system, you will see that all these things actually come into play over there, and you should pay attention to all these conceptual things and take into consideration the pros and cons of all types of file organization or index structures, because you might be given in the let's say paper scenario that these are the sort of types of queries or these are the type of updates and frequency of updates you are getting, and then you might be asked to design a relational database system in a sense that table structure, and design the types of index you might want to create on it. So the last type of indexes that we are going to consider are primary versus secondary indexes. Primary index is an index on the set of fields that includes primary key, and secondary indexes are all the others. So the term note over here at the bottom that I have mentioned, the term primary index and secondary index are sometimes used with different meanings in different textbooks, but for the purpose of our course we are going to use this terminology. And the reason why primary and secondary indexes actually are sometimes used interchangeably with clustered versus unclustered index is because oftentimes in database file organization, the set of records are oftentimes sorted according to the primary key. I mean, if you created a table out of existing records rather than inserting one record after another at some interval, then oftentimes the records are created already stored on in the file according to the sorted order of the primary key, and that is actually, that should ring you bell, that is exactly how your clustered index is. The order of the keys in the index is same as the associated order of the row IDs or record IDs. So which is why primary index can often be considered as a clustered index and secondary index as unclustered index. But remember that for this course we are going to use this terminology that I just discussed. So the only other like miscellaneous type of indexes is you can, it is not necessary that you have to create index only on one key. You can also create index on composite keys. And as you can see, this is one table in the middle of the figure which has 3 columns, and you have 4 different types of indexes created on it, all unclustered by the way. So one is a composite on age salary, that is age sorted first and then within that salary second. The second type is first you consider salary and then sort on the age, and the other two are just based on age and salary. So here towards the end of the chapter, here is just a quick peek at how the SQL command for index creation looks like. So you just say create index and you give a name to the index on student so and so with structure equal to B3, and this is something that we are going to start discussing from the next chapter onwards. And the key basically mentions the sort key of the index. So by the way, this create index command might look like create table command, but let me remind you that when you write SQL queries, you never ever actually use the indexes. You always use base table names, and which index to use is oftentimes a task left out to the query optimizer. So here we are ending our chapter 8, and from next chapter onwards we are going to start discussing details of different types of indexes, costs associated with it, which will sort of get you warmed up for the topic of query optimization that comes after it. All right, thank you.